Algebra 1. Today we are going to be simplifying rational expressions. Now I'm going to break this up into 2 videos, so here is part 1. The objective here is to simplify an algebraic fraction or a rational expression. So here's our first example, simplifying an algebraic fraction. Say we have 4/18. Now some of you may remember how to reduce this. You want to find what they both have in common on the top and the bottom. Now if I rewrite the top and the bottom, I could rewrite it as 2 times 2 over 2 times 9. Notice those 2's are highlighted in red. Now if I've got 2 divided by 2, that's really just 1. So those things right there, they actually cancel out, right? So I'm left with 1 times 2 on the top, 1 times 2, 9 on the bottom, which leaves me with that fraction reduced down to 2/9. So our goal here is to look for these big ones, right? Just like on that fraction where I was able to cross out a 2 on the top and a 2 on the bottom, I want to do that in other algebraic fractions, maybe ones like this. So what you want to do is you want to factor them. You want to break them up into their factors. So one way I'm going to do that is on the top I've got 5 times x squared. Well, another way to write x squared would be x times x. And I want to break these up so that I can find common factors, right? I want to find these big giant ones. So I also want to break up 15 into 5 times 3. If you notice, that gives me a 5 on the top and a 5 on the bottom. There's my big one. And it also gives me an x on the top and an x on the bottom. So you want to find these pairs. All right, so I found these big ones. That means I can cancel out the 5's. I can cancel out the x's, which leaves me with 1 times x times 1 on the top. And it leaves me with 1 times 3 times 1 on the bottom. When I simplify that, I'm left with x over 3. All right, so we're going to try this one. If you think you got an idea of it, go ahead and pause this and try this on your own. But we're going to go ahead and work through this right now. So I've got 48x cubed times y on the top. First off, let's talk about what x cubed means. X cubed means that I'm looking for x times x times x. It's just a short way to write that. I have a 48 on the top, a 20 on the top. I'm looking for a way to break these down. One way I can do that is by finding a 4 on the top and a 4 on the bottom. Hey, look at that. That gives me a giant 1, right? 4 on the top, 4 on the bottom. I've got a 12 and a 5 on the bottom. That doesn't give me a big giant 1, and I can't break up that 12 so that I can make a 1. So I'm done with those numbers. Next, I'm going to look at the variables. I see a big giant 1 with the x's, so that means I can cross them out. Next, I'm looking, I don't have any more x's on the bottom, so I'm going to move on to the y variable. I can make another big giant 1 with the y's, and I can cancel them out. So when I say a big giant 1, because notice you can put a big, this is my 1. See that? That's my 1. Because these turn into 1. When they cancel out, 4 over 4 is just 1. X over x is just the number 1. Y over y is just 1. So when they cancel out, they really don't go away so much as we don't have to write them because they're just 1. So when I simplify this, all I'm left with is 12x squared because I've got x times x here. See that? X times x, the shorter way to write x times x is x squared. And I've got 5 times y on the bottom. All right, so in our other examples, we were multiplying variables and numbers. In this example, I'm adding variables and numbers. So here I have x plus 3 in the numerator, and I have x plus 3 also in the denominator. And when I'm talking about these, I want to talk about them as quantities. I want to put parentheses around these and treat this as a whole number. X plus 3 is a number. And same thing on the bottom, x plus 3. Now, this one, the same is on the top, that's on the bottom. So I have a giant 1 here. This doesn't really look like a 1, but it is, right? I can cancel these out. So this is 1. It's the same on the top, same as on the bottom. Very straightforward. Now here's where we start to kind of maybe get tripped up. This is where a common mistake usually occurs. All right, like I said, we want to treat the top as a whole number right here. We can't separate the x and the 5. The x plus 5 is a number. Same thing on the bottom. X some number plus 3 is a number. All right, so top, everything stays together. On the bottom, everything's going to stay together. This is one number. Common mistake is that people want to cross off the x's and say, oh, this is equal to 5 over 3. And that's not true. This is not equal to 5 over 3. I mean, let's just test it with a few numbers. Let's say I said x was 10. All right, so 10 plus 5 over 10 plus 3. Well, that would be equal to 15 over 13, which doesn't reduce down to 5 over 3. All right, so I can't just cancel out these x's. Let's try 100, right? So 100 plus 5 over 100 plus 3. Get 105 over 103. Again, doesn't reduce to 5/3. So what's the answer? How do I reduce this fraction? Okay. It just stays the way it is. X plus 5 over x plus 3. And that's it. I'm done reducing this. There was really nothing I could do. So don't make the common mistake. Don't cross those x's off. Don't tell me this is 5 over 3. It is just x plus 5 over x plus 3. I want you to look at reducing these ones. Again, we want to look at these expressions, these binomials. They need to stay together. If they're in parentheses, they need to stay with their people, okay? So x plus 1 is some number. So I'm looking for something that I can make a big giant 1 with x plus 1. Something that matches this set of parentheses. And look on the bottom. I've got an x plus 1 here. Okay? So this thing right here creates a giant 1 because x plus 1 needs to stay together. So x plus 1 and x plus 1, they can cancel out. And I'm left with just x minus 5. I'm left with x minus 5 because this x minus 1 on the top becomes a 1, and so does this x plus 1 on the bottom. It just becomes a 1 since they cancel out. They don't go away. They become a 1. And x minus 5 over 1, well, any number divided by 1 is just itself. So I'm left with x minus 5. Down here, again, I want to find some things that match. I see in parentheses here that I've got 2x minus 5. I see over here I have grouped 2x minus 5. So guess what? I can create another big, giant 1. All right, that means this cancels out and that cancels out. Here is a big mistake a lot of people like to make. They like to just say that the answer to this is x plus 3. That is not true. You cannot forget this 1 that's up top here. All right? If x plus 3 is in the bottom, in your final answer, x plus 3 better be in the bottom. So the answer here is actually 1 over x plus 3. All right, this is where I'm going to stop the video, and you can check out part 2 for what's coming next.